All right, make sure we're rolling here. We are. All right. So day 2 of some things with simple principal. How much principal would it require for Amy to earn a return of $530 in 7 years at 5% interest? Why would I want to figure it out that way? Maybe there's something I'm needing to purchase down the road. Maybe I'm doing a down payment on a house or a car or something. Now, 7 years is a long time to think ahead, but for something shorter, this might make sense. So, here, they switch the formula around on us. Now, we have a choice here. What they chose to do is take the interest formula, that is a P, and decided to solve for principal. Now, I'm not sure I'm giddy about this idea, but I'll show you one, and then you can kind of see how you want to do this. If I want to solve for the principal, if I want to know what that is, and we're doing this like a math equation, I'm multiplying it times rate and time. What's the opposite of multiplying something? Division. So, I could say that principal equals interest divided by rate times time. Now, here's where I'm not giddy about doing this way. Because now, I can still plug in my values here. The principal, well, let's see. My interest would be $530 divided by. If I divide 5 by 100, that's 0.05 times my time. You're like, it's right there. I'm like, I know, but I want you to see it in a form that might be a little more sensible. And so, if I go that route, let me try and brighten this up a little. I've got to remember to put the parentheses in the denominator, or it may not work. And so I'd go ahead and I'd get my value. And they rounded differently than I did. It's 29, it's not 28. So they're showing where all these numbers plug in. But here's what I need to know from some of you. What if instead of doing all that manipulating at the start, I said, you know what? I'm not going to change anything. What I'm going to do is I'm going to say, okay, interest equals principal times rate times time. That's what we were pounding away at yesterday. Now, with the color scheme, I've got P I don't know, so that's the mystery value. Rate was 0.05. Time was 7. And my interest was $530. I just labeled things quick. You're like, we're doing the same problem? We are. I just want to see which one's going to be easier for us. So now, if I just keep this the way it is, I'm going to plug the numbers in. I'm going to substitute where those values go. So I don't know principal. I'm going to leave that as P. Times my rate times my time. So now, I notice that over here on the right, okay, I can't do anything with the P in the calculator, but if I'm multiplying these other things together, 0.05 times 7, okay, I get 0.35. And if I ever get flying along, because sometimes when I'm doing this, because I like it, I'm getting going along and I'm just going and I'm like, oh, and people are like, dude, you're going way too fast. I'm like, okay, I'll slow down. But now we're down to just one step already. All we do is plug numbers in, and we're down to one step. The opposite of multiplying, p by 0.35, would be to divide. And we end up 530 divided by 0.35 in the exact same place. So if you were on your own and I'm like, I'm not going to tell you which route I would have you go, if you're solving for something besides interest, the principal, the rate, or the time, would you rather solve for the variable and plug it in, or just keep the same formula all the time and just plug the numbers in? Okay, so for the time being at least, if some of you still want to go that way, you can. I'm just going to keep that and kind of roll that through. And with what I was able to see quickly in the few minutes that we worked yesterday, was that our biggest thing is labeling what is what, which is where I saw some of the confusion coming in. So, okay, let's play with another one of these. This is interesting how we're playing so far. Okay, so we're going to flip ahead here to 5. So again, same idea. However, again, where I took this from, wanted to solve for the rate. So I'll just kind of put that here. The rate would be interest divided by principal times time. If you like going that route, you can. But if we're going to keep doing it the way that we think is going to be good for us, okay, we'd go, okay, even in a problem like this, I don't have to write everything out individually. I can just go to the problem and say, okay, I took out a loan for $753.06. That's my principal. That's how much I'm starting with. For 7 years, there's my time. And the interest charged is $369. Okay, the interest, not the rate. What is the rate? R is the mystery value that we're looking for. So, I do my interest, principal, rate, time, and I just start plugging the numbers in that I labeled. I is 369. Principal is 753.06. I do not know the rate, but I know the time. Hey, and you don't have to when you're... Oh, I'm sorry, go ahead. Sure. Uh-huh. So, again, the side that has the variable, we're going to have a little extra math we got to do here. 753.06 times 7. So, 369 equals 5271. 42R. Because the R is still there. So, again, we're multiplying all this stuff by R, so we're going to go ahead and divide it out. We should get a really, we should get a really small decimal number here. And we do. So 0.07, but that's not the answer, because we want the rate. So since we want to go decimal back to percent, we multiply it by 100. And end up finding our rate. So you'll notice from the one we did prior to this, with finding the principal, and this one we were finding the rate, the math really was no different. We still multiply two things together and then divided it out. It's going to be no different whether we're doing principal or rate or time. I just have to know what thing am I looking for to make sure that I'm in good shape. So, with that in mind, last one. One more flip. One more flip over to 7 here. Okay. If I want time, you know the drill here. Now, kind of pay no attention to your stuff here. I'm going to freeze frame here for a minute. Label your pieces. And you're going to be looking for your time this time. I'm going to unfreeze it here after a moment, but label your spot, your pieces. I will come back in here momentarily. But sometimes having colors for your different pieces of this can just make things flow a little bit better. And then we'll see if we all get same thing here, or close at least. We may round a little differently, but get those two values on the right, multiply those together, divide by whatever that gets you, and you should have your time. But we're going to have to discuss one thing with the time, because there's a twist that can come into this one too. So if I get my values in, again, you may be slightly different from me on the decimal if you rounded differently here. Like if you look, you're like, well, it's down, I'm going to use 95. That I would say that's a little too much rounding. You want to go to at least a couple of decimal points with these. And so when you divide, you get like 1.15, which would be the number of years. So I can get decimal years, you can. And if you wanted to turn it into days because it was so short, you can multiply by 360. That's an interesting idea. I'm going to look deeper into that. I wonder if banks actually do that. That's weird. Like, there's not 360 days in a year. There are 365. Ooh, I got something to go dig into. Okay, I will report back on that tomorrow. Because I've never seen a year put into 360. Unless that's something else new they're going to throw at us. Just haven't told us yet. So, yeah, just stick to years for now. Stick to years. We need to go to days. I will dig deeper into that. That's just odd. Okay. Before I do any more talk of interest of any sorts, any questions on how we're going to tackle these? Whether it's finding interest, we just multiply them together, or any of the other three, plug in the numbers and we're just going to multiply them together and then divide, no matter what thing it is. So I just want to make sure I don't leave nobody behind as we're going through with this. Okay. I got one last twist to throw in. Just one. Just one. One more flip. At least we're going to be back to a normal looking page, which is a nice thing. We're not going to pound away at all of these. We're just going to do a little bit So we make sure, kind of, and give ourselves a little bit of a challenge here. So, okay, compound interest. This is the type of interest we were talking about the other day when I showed that short Dave Ramsey clip on how if you start investing early, you'll be a millionaire before you retire. This is where you have some money and you get some interest, and then when you go into like the next year, you're making money on your principal plus the interest that was in there before, and it all keeps stacking. That's the compound part. Because you're not just getting your money on your principal, what you started with, but also any interest that you've earned so far. So, this is what's so cool about this one. So, compound interest earns interest on the principal. Again, if you like looking at that, that's the original money. You do that. And any previously earned interest. That's pretty cool. They're giving you money on the money on the money on the money. So, the interest, as you earn it, just gets added back into the principal. So it's not like you're taking that money and putting it in your pocket. You're leaving it in there for a rainy day and you're getting a little extra money because of it. So, because we're keeping that money in, it grows more quickly than simple interest does. If you had the same principal, the same percentage, but for a different time, the compound will go faster. So, I'm skipping A for a moment because we know what the last three are. How much I started with, still the principal. Okay, again, that's still my original money, if you want to look at it that way. R is still our rate as a decimal. So if they give us R, if they give us the percentage, we're going to divide it by 100. So we can turn it into its decimal form. That hasn't changed. Time is still in years. So now, though, instead of that just equaling I, we have this new part in A, which stands for the total value of our investment, including how much I put in to start and all the interest that's been earned over all the time. So principal plus, it's like the PI. So the compound interest formula that we have here, P times 1 minus R to the T, okay, helps us find the total value. Now, if you wanted for some reason to find out just the interest, you would subtract the principal from the total amount. So if, for some reason, I just wanted to know the interest, not all the money in my pocket now, I would take the total minus the principal. So I want to make sure we kind of lock in on this part, because this has one extra little twist that the simple didn't. So if I do something that you're like, hold on, Hardy, what are you talking about? Jump in and stop me right away. So let's keep labeling stuff. All right, so we borrowed $2,000. There's my principal. Or if you want to squeeze letters in there, I suppose you could. Borrowed at a 4% annual compound interest rate. Again, take your percentage divide it by 100. And that is our rate for 2 years.
He's back.
So, I got P, I got R, I got T. The only thing I don't have is A. That's what we're going to go looking for. So, A equals my principal 1 plus my rate to the T power, not times T. So that brings a whole new thing in here if we're going to use the calculators that are in here, but we can get this figured out. So here's how this is going to work. 2,000, okay. The parentheses are right above the 8. 1 plus 0.04. When you go to do the exponent, okay, if it's just 2 or squared like it is, there's a button for that, but that's not the one I'm going to show you because I want us to be flexible. The button right above divide, that little up arrow called a caret, that's what we're going to use for our exponent, and then put our number. Depending on the calculator you use in here, if you're using one of the silvers like I am, I'm going to go grab one of the yellows too if there's still one back there. Just so you can see the difference, that it's the exact same thing. Even though it's going to look weird. So, as you can see, the gray one, you're just going to see the little arrow in the 2. That's your exponent. If we do it on... Get me out of there. If we do it on the yellow, and this way I can show I get the same answer both ways. And I go to do the exponent button, it just puts the little square and it looks more like what you would see like on a computer or something. So both of them are going to get me the same thing though, which is 2163.20. Oops, total value. 2163.20. But what if I just want to know the interest? I'm going to do 2163.20, my total, minus my principal. And that'll get me my interest. So if they're straightforward, that's the game we're going to play with this as we're trying to work through them. Now, are there some places that can kind of mess with this? Yes, there are some minor things that can come up. I only got 2 examples left. So I look and I go, okay, Tori's buying a new $500 microphone for her YouTube channel. It's not a terrible idea. So that's my principal. Okay. She takes out, a 24-month loan. Yes, don't use 24. My time is 2 years. If they tell you months, you divide it by 12 because that's how many months there are in a year. So I got to read carefully when I'm doing this. With an annual compound interest rate of 3%, 0.03. Because again, we're dividing by 100. How much will Tori pay in total? Okay, this one's going to be straightforward. $500, 1 plus my rate, decimal form, to time. So again, it doesn't matter which calculator I use. I guess I pulled this one up. We'll go with this. So this time they didn't ask for the interest and all that stuff. They just wanted to know Tori spent $530.45 total on the microphone once she's done with stuff. Again, we just got to dig and get the pieces. All right. One last one. Then I'll show you how we're going to kind of practice and let you loose on some stuff here. Adam's saving for retirement. He deposits $10,000 into an account for 25 years. If the account has a 2%, Adam needs a better investment plan. 2% annual compound interest rate. How much interest will Adam have earned? So be careful. We'll still use our regular formula here, but when we get done, we're going to want to make sure that we subtract our answer from our principal so we can actually get the answer we're being asked for. So my A is going to be 16,406.06. But that's not the question. That would be my total. But for interest, I'd have to subtract the 10,000 that I started with. That's a pretty good chunk of change, except after the fact you think, you're like, well, wait a minute, though. I had no access to that money for 25 years, and with inflation, it's probably worth even less than my original 10,000 now at this point. So, here's what I want you to do so we don't have panic in the streets here. And again, multiple days to be able to do this. So, stick with me and date and label stuff. Okay, the compound interest that we just did. Work through these. The answers are at the bottom. If you want to do the puzzle that goes, do the puzzle that goes. It actually does a phrase this time, not just random letters. But if you just want to do math with it, that's fine. Okay? That's for compound today. Then we're going to go backwards. Like, how far are we going, Hardy? Oh, we're going. Let me get that out of the way. Oh, get that out of the way. Okay, so we started here on 3. On the back of each of those weird slide note pages, there's some examples. You are not doing all of the evens. Oh, dear gracious, no. I'm not that crazy. 2 through 10, 5 problems. Okay, so 5 where we're strictly looking for the principal. And for each of those little mini slide pages we did, so this is page 4. Just keep thinking evens, people. Evens is the name of the game for this today. Okay, finding the rate. Page 6. Evens. 2 through 10 evens. 2, 4, 6, 8, 10. That's it. Because again, I want to make sure any of those detail things that still might be hanging you up don't hang you up. Because, as I do one last one, and some of you are thinking I'm crazy, here's my thing with it, though. I don't know if it's going to be tomorrow or Thursday. I can stop this because I'm done explaining things.